Oh, hi there. Thanks so much for showing up your math learning. It's Mr. Jennings, and we are looking at graphs of sine and cosine using radian measure. So this is this is our review lesson essentially from grade 11, but in grade 11, of course, we were working with 360 degrees. In grade 12, we have introduced the idea that 360 degrees also equals 2 pi of a circle. And so we measure angles in radians now. So this actually will tidy up our graphs a fair bit because we don't have to worry about large numbers that are unnecessarily being multiplied by 360. Now we're just multiplying by pi. Okay, so let's dive in. So sine and cosine are these functions. Cosine starts at the maximum. So you can visualize this as this is y equals 0 here, y equals 1, and y equals minus 1. Cosine starts at the max, hits the midpoint and goes down, hits the minimum, comes back up and hits the maximum again at 2 pi. Okay. Sine, on the other hand, starts in the middle and goes up to the maximum, down to the middle, down to the minimum, and then back up to the midline. Okay. And one of the useful metaphors that you can use to remember this is this is like your summer at the top. This is your winter. And when you're going from summer to winter, this is the fall, and this is the spring. So here we are, spring going to summer in our class, but depending on when you're watching this, that may not still be true. Sine, on the other hand, starts in spring and goes towards summer, okay, and then goes to fall, winter, spring again. Okay, so these are super useful ideas because on one hand, it really helps us graph them very effectively. Here's 2 pi. Well, we can see that after pi, half the period, we should be either back at the midline but going in the opposite direction, or, well, actually it's the same over here. There's half of our period, or half of the period is the amount of time it takes to go from a max to a min. Okay, there's half of a period there. Another thing that we can see here is that the quarter periods are really where we get some significant points, and we can use those in a really effective way. So the sine function, when we take the sine of 0, we have sine equals 0. Sine has its maximum there at pi by 2. Sine hits another minimum there. Hits the axis at pi, and then hits the minimum at 3 pi by 2. That's down here. And then we're back to spring over here. So this is spring, summer, fall, winter, spring again, and divided up nicely into the quarter periods. And so how do we know that the quarter periods? Well, our period is 2 pi for all of these when they don't have a k transformation. And if we take 1/4 of 2 pi, well, that's pi by 2. Okay, so there's our quarter period. And that matches nicely with what you're seeing on the unit circle. We start at 0, we go to 1, there's a pi by 2, and then we have pi here, we're back to 0, we're at minus 1, that's 3 halves pi, and then back up here for 2 pi. So each one is a pi by 2. Pi by 2. Okay, so that's how we're seeing that one. Cosine, on the other hand, starts at the summer and goes towards winter by its first half period. And again, you have the quarter periods there and the same location. So really, if you're using that metaphor, you're going to be fine with those. Now, these periodic functions, when they're unmodified, they always have an amplitude of 1. Okay, amplitude is measured as the distance from the midline to the maximum, or the distance from the midline to the minimum. Okay, and it's 1 unless we have a modification. And then the period, in both cases, we've already talked about how that's 2 pi. We might be changing that in different situations. Okay. So, and we can also talk about these as peaks and troughs of the wave. These can literally be waves, and you can analyze them with sine and cosine graphs. Amplitude is, of course, 1. All right, so when we have the function in its fully transformed version, This is where our various transformations showed up last year. A refers to the vertical stretching of the function, and that corresponds directly to amplitude. And by corresponding directly, I mean it just equals the amplitude, because if you have like f of x equals 1 times sine x, there's your amplitude. It starts at 1. But if I change that to say 10, I'm multiplying the whole function by 10. It stretches. The amplitude is now 10. The k corresponds to the period and squeezes or stretches the period depending on the value of k. So we will see that k gives us this formula. 2 pi divided by the period is the value of k. And period equals 2 pi divided by k is the opposite type function there, the formulation there. And we're going to use that to calculate the various periods when we're graphing. If you can see the period and you want to know the k value, you'd use this formula to calculate the k value. This is the same thing that we did last year, but last year we had 360 degrees divided by k was the period. But now we have 2 pi there. Okay. And then d and c. D refers to how we shift this function left and right. And c is we shift it up or down. This one already has its sign flipped in the form, so we tend to read like x minus 5, let's say, is a shift of 5 to the right, and then x plus 5 is a shift of 5 to the left. And c is changing our vertical movement of the whole function up or down. So here's a handy Desmos visualization for us. So notice that when I change c, I change the position of that midline. Okay. So if I set it to 0, I have myself a good old sine function with no transformations. You'll notice it finishes its first full period at 2 pi, and so on. Okay. What if I made a negative? Well, negative sine would look like this. Okay. It starts in fall and goes down. It goes fall, winter, spring, summer, instead of spring, summer, fall, winter. Okay, so we're just, really, you could do that by shifting it left or right. But when we have, like, say, a is quite large, like 10, then we can see that our amplitude is we go up to 10 and down to minus 10. Okay, so there's some ideas there. Setting this back to 1 there. Okay, so now when we change k, like let's say I make k 2 or 3, see our period is being shortened. So there you have the full period happens by 2 pi by 3. Look at that, 2 pi divided by 3. K is 3. There's our little mini formula, right? And then I have d as something I can shift around here. So notice that that just changes the starting position or where we find this one. Yeah. Cool. All right, so that is our handy dandy visualization. Let's keep going. All right, so now when we have these a values, that absolutely corresponds to amplitude. So let's go ahead and graph some. If you have f of x is equal to 2 sine x, what I would do is just get my quarter periods. So there we go. There's 1 and there's 1. I know that it starts at spring and ends at spring. So there we go. The next thing is right in the middle. My half period is back here, but that's fall. And we are a vanilla flavor of sine, so we go to summer first. My quarter periods is 2 pi divided by 4. That's pi by 2. So I just map out my quarter periods and make sure that I have my scale set correctly. So there, that's the amplitude. Whee! Make sure you get these rounded, nicely rounded. And another tip is that the 12th period is where you hit your halves. And you hit them right after and right before spring and fall. Okay, so 1/12 of the period before, or pi by 6, before pi and after pi, we are at the 1/2 way to the minimum or maximum. Advanced tip. Okay, if we have g of x is negative 1/2 cos x, well, let's set this as minus 1/2 because we only need to see from 1/2 to 1/2. This is then a quarter, and this is minus a quarter, and we are negative cosine. So cosine starts in the summer and goes back to summer. Negative cosine is just a reflection of that. It starts in the winter and goes back to winter. So I put it on at the winter position, it finishes in the winter position, and at its height in the middle it's in summer. And again, I just try and hit those halfway points, get it nicely rounded. And that's how we will graph an amplitude shift, also a negative cosine. Okay, the k value is going to change our period. It's not equal to the period, but it's related, and we just need to remember that little fancy dancy formula here. So we have 2 pi over k. We're going to use that. Let's go. So f is equal to sine 3x. Let's find our period. Okay, how many times are we going to go through this here? 3 times. We're going to go through 3 periods per 2 pi. We're going to go through k periods through 2 pi. So 2 pi on 3 is our period here. And so what's our quarter period? So let's find it. 2 pi on 3 multiplied by 1 on 4, and that gives us pi on 6. This is our new quarter period. Cool. So fortunately enough, that's pi on 6, that's pi on 3, that's pi on 2. These are all pi by 6s, all of these little increments. Okay. So the first time that we go through a full period here is 2 pi by 3. That's right there. The next place is 4 pi by 3. That's right there. Notice that cuts this perfectly into thirds. We have 1 up here and minus 1 down there because we have not changed the amplitude. We start in spring, we end in spring, we go through fall exactly in the middle, and first point of interest is summer. So we go to summer, come down to fall, we hit winter after this quarter period, and back up. And some of you might be wondering, well, how did you know that each one of those was pi by 6? And the sixths have this like nice habit, right? Like if I go 1/6, 2/6, I get so many reductions here, right? 3/6. If I reduce all these, that's still a sixth, but then this is 1/3, and then this is 1/2, right? These are all equal. The next one is 4/6, which is there, which is the same thing as 2 pi on 3. Okay, so that's how I know. All right, and then that kind of fractional thinking is just going on behind the scenes. Okay, and if you want to bring your fractional thinking front and center, that's a good way to avoid errors. So there's a nice graph of sine 3x. Cosine 1/2 x, well, we would find out the period by saying, well, it's 2 pi divided by 1/2, which is the same thing as 4 pi. Ooh, so we only get half of a period here. Cosine starts in the summer, and we want to know, well, what's our quarter period? Well, we take our period and divide by 4, and that gives us pi. So this is our quarter period, so we will hit the fall there, and we will hit winter here. And we are essentially seeing just 1/2 of a full cycle there with cosine of 1/2 of x. Okay, the d value, shift things left or right. It's kind of tricky. So here, what I would suggest, this is my suggestion for how you graph these, is go ahead and sketch this one in a very light color and then shift. Okay, so I'll go ahead and graph my sine function, which normally is there, spring, spring, summer, fall, winter. Maybe I put in a very light, so light. Don't put it in too heavy. Okay? You don't want to confuse things. And then we're going to shift everything. We can really just shift those 4 points. Okay, we're going to shift everything negative pi by 6. So that is pi by 6 right. So this one goes here, this one goes here, this one goes here, this one goes here, and this one goes here, but we're off the graph. I happen to know that that one is right there, and that one is right there, and comes up, and then comes up here, But let's say I didn't know where my y-intercept was, and I want to know like where, I can see it's like fall going backwards in time, sorry, spring going backwards in time to winter. But where on the axis is it? Suppose I don't know, input 0. Okay, so we're just going to evaluate. We're going to say f at 0 is equal to sine of bracket 0 minus pi by 6. And so negative pi by 6 is this angle down here on our unit circle, and that's minus 1/2. So we are there at negative 1/2. So we just put it in, just evaluate and solve it. Okay, there, that was our graph for that. And it starts and finishes in the same spot because we are seeing one full period. Okay, cosine of x plus pi by 4, again, exact same strategy. Sketch, it starts in summer, goes through fall, winter, fall, summer, sorry, spring, this is spring, I mislabeled it. Okay, and then maybe I do my dotted lines or maybe I don't. This one is pi by 4 left. So pi by 4 is half of pi by 2, so this one goes left there. This one goes here. This one goes here. This one goes here. And then we're going to finish in the same place we start, but where do we start? Like about where is it? Well, it's about there, isn't it? It's a little bit bigger than a half. Actually, it's a little higher than what I just drew, but I'm not too fussed. I'm just going to evaluate g at 0 is equal to cosine of 0 plus pi by 4. And cosine of pi by 4 is root 2 on 2, which is equal to 0.7-ish. So if this is a half, we are a little bit higher than that about there. Okay. All right. So that's how I would do these. And then the c value just represents our vertical shift. So if here you have, this is 2 and this is 4, and this is minus 2 and this is minus 4, sine starts in the middle and goes to its maximum, goes back to the middle, oops, and then back to the minimum and then back up. But it has an amplitude of 1, doesn't it? So that was incorrect. Okay, so this one looks like this. And one thing that can help you with this is just putting in your dotted lines, like that. This one we might have a dotted line here at -1. Oh, breakfast, great. And cosine starts at its maximum. So there's the maximum, which is the amplitude, right? I'm just thinking my amplitude is 1 above this middle line, which is at -1 through there. Okay, so if I start 1 above that, and every quarter period I either hit the axis or hit the minimum or hit the axis or hit the minimum again, and then I just go through and join these with a line, and then I'm done. So when we're thinking about domain and range, we are thinking about, okay, we have c plus c plus the amplitude is our maximum, and c minus the amplitude is our minimum value. These shouldn't surprise us too much. And so this is for range. Domain, on the other hand, like I can squiggle and just keep going in either direction. There's no limits to what we can input to these functions for sine and cosine. So that's no problem. We'll generally have these restricted, like through a certain time frame or through a certain number of revolutions. So, so here the x's of the reals, or just like you would say -infinity to infinity, is our domain, and the range is including the minimum and including the maximum. So if we wanted to state the domain and range of these, x is of the reals, and our maximum value would be 3. So we have -3 is less than or equal to y, which is less than or equal to 3. Our minimum and our maximum is 3 there. If, on the other hand, I had +7, out there, both of these just get bigger by 7. We would have a minimum value of 4 and a maximum value of 10. Because 7 minus the amplitude is 4, that's a min. And 7 plus the amplitude is a 10, that's a max. Okay, so find those, pretty straightforward. Here, our amplitude is 1. And 1 minus 2 is minus 1. Okay, so that's our maximum actually for this one. And then minus 1 minus 2 is minus 3. That's our minimum. So this one as well has the range of minus infinity to infinity. Okay, that's our range, but our domain is minus 3 comma minus 1. But inclusive, my goodness. Okay, so we include the maximums and minimums. All right, so go ahead and get some practice. And any questions, hit me up by email or in class. Bye for now, everyone.